These are notes for section 3.1, which is going to just be a review on basic fraction operations. In chapter 3, you're going to be working with what we call rational expressions. And those are fractions that have variables in them. And if you can factor, you'll be pretty good. And if you know how to work with fractions, we combine both of those skills in this section. So today is just going to be a little review of just can I simplify, add and subtract, multiply. That's supposed to be an asterisk for multiply and divide fractions. So I'm just going to do 2 each of each of those skills, and we'll have a nice little short set of notes. And then there's a worksheet that has 10 problems of each skill on it. So first thing, just making sure we can simplify fractions. So let's put that on here. Simplify. And again, this really isn't in the next chapter. This is chapter 11 in your book. And really, they don't have any non-algebraic fractions. But we need to practice a little bit first without the variables just to refresh our brain from 5th or 6th grade. So if we are simplifying 18 over 32, without any variables in it, remember from elementary school that all you need to do is find the biggest thing that you can divide out of both of those. And there's a 2 hiding in 18 because it's even. And there's a 2 hiding in 32 because it's even. The 2's cancel, and I get 9/16, which I know is done because the only thing that goes into 9 other than 9 and 1 is 3. And 3 doesn't go into 16. And then the question is, do I really have to show this, Larude? And the answer is no. I'm doing it because when we have variables and expressions, that's going to be kind of important that you realize that you're actually canceling a 2, even though in your head you're just dividing it out. So yes, you can go right to here on your worksheet and just divide out a common factor, but it's really important that you know that you are canceling. So we'll do one more. Suppose we have negative, and let's say 24 over 36. Now your goal is to get it simplified all the way down. You don't have to find the biggest thing that goes into both, but if you miss it, you need to know that. So watch. Let's suppose you look at those and you're like, for sure 6 goes in. So you say, I'm going to knock a 6 out of the top. 24 divided by 6 is 4. And I'm going to knock a 6 out of the bottom. What this tells me is you didn't find the biggest thing because 4 and 6 are still even. So what that means is I can still hack out another 2. So I'm going to divide a 2 out of the top and a 2 on the bottom. So you don't have to get the biggest thing as long as you realize if you don't, that you're not done. Really, if I could take out a 6 and then divide out a 2, what that means is the biggest thing was a 12 that I could have knocked out. But you don't really need to stress out about finding the biggest thing as long as you can find something and then just keep chopping at it until you're 100% sure you're done. So that's all I'm going to do with that because I'm sure most of you know how to do that already. Next up is part B, and we're going to review how we add and subtract just basic fractions so that when we get into the algebraic ones, we at least have the process down. Addition and subtraction both require a common denominator. Doesn't have to be the LCD, but it really is best and in your best interest to find the least common denominator. So let's do one addition and one subtraction problem. Suppose we're doing 2/3 plus 1/4. I need the smallest thing that both 3 and 4 go into, and that one's obviously 12, but don't make the mistake of thinking that you always multiply those. You don't, but this one I could easily spot. So I'm going to change each of those into 12. When I do that, I'm really multiplying that bottom by 4, so I need to do the top by 4. That'll give me an 8 over here. I'm really doing this bottom by 3 to get the 12, so I need to do the top by 3. Once I have a common denominator, I keep it, I don't add them up, and I add the tops, and then I give it a little glance to make sure it's simplified. Subtraction works the same way. Suppose I'm doing 7/12 minus 1/8. I need to find the smallest thing that both 12 and 8 go into. The easiest thing to do is just grab the bigger and ask yourself, does 8 go into 12? And the answer is no. So then I go to the next multiple of 12, which is 24. Does 8 go into 24? And the answer is yes. So what I do is I walk my way up to that least common denominator. So I know that I'm going to be using 24 and 24 as my LCD. Notice I don't get that by just multiplying 12 times 8. I really just need to kind of grab the bigger one and keep bumping it up until the little one fits into it. So this one needs to get doubled to make a 24, so I double the top. This one needs to get tripled to make a 24, so I triple the top. Now that I have a common denominator, I keep it and I subtract the tops, and then I make sure it's simplified. If that had been 12 over 24, I would have to knock it down, but that one is simplified already. So adding and subtracting is all about an LCD. Multiplication of fractions. All right, so let's say we have 2/3 times 9/8. We really just multiply straight across, but when the numbers or the factors get really large, that's really not a great idea. So what we do is we cancel top to bottom. You don't cross multiply, you cancel on the bottom. So you say, is there a 2 living on the bottom? And the answer is yes, there's a 2 hiding out in 8. So I'm going to divide a 2 out of the top. I'm going to divide a 2 out of the bottom. Then I look at my next one, the number 9. Is there anything in 9 that I can chop out on the bottom? And the answer is yes. I can divide a 3 out of 3, and I can divide a 3 out of 9. Now I can multiply straight across, and I'm going to get 1 times 3 is 3, and 1 times 4 is 4. And that doesn't reduce any farther, so I know I'm done. So with multiplication, it's not about getting a common denominator. It's about canceling and then multiplying straight across. So we'll try another one of those. So another example of the multiplying. I might need to flip your, whoopsie, making lots of noise here on my thing, but here we go. Let's suppose we were doing 12 over 20 times 8 over 18. I can cancel anything I want top to bottom. I could take a 2 out of the 12 and a 2 out of the 20. I could take a 4 out of the 8 and a 4 out of the 20. It really doesn't matter. I just have to start chopping it down top to bottom. I could even do it diagonally as long as it's on the top and the bottom. It is legal for me to take a 6 out of here and a 6 out of here. It's totally legal. Next up, it's legal for me to take a 2 out of here and a 2 out of here. Or maybe I want to take a 4 out of the 8 and a 4 out of the 20. It doesn't matter as long as I'm canceling top to bottom. I like to take big chunks out. So I'm going to divide a 4 out of that 8 and a 4 out of this 20. Once I think I've got it all knocked down as much as I can, that's when I multiply straight across. 2 times 2 is 4, and 5 times 3 is 15. If I missed a canceling in that process, it'll show up in my answer because what I get right here won't be done. It'll be like 6/8 or something where you're like, hey, that's not done. Well, then just divide it out again. All right, so last thing you need to know how to do, and then you'll go get a worksheet, is how do I divide fractions? And if you can multiply, you can divide. So the last thing, I think I'm on D, is division. And division, and I'm going to ask you this when you come up to see me, division is the same as multiplying by the reciprocal. It seems kind of weird, but here's the deal. If I had, let's say, a cake that had been cut into 8 pieces, and if I say I'm going to divide them each in half, so I'm really doing 8 divided by 1/2. Most people would say that's 4. It's a kind of a common game show question, is what's 8 divided by 1/2, and everybody spits out 4. But when I divide each of these in half, you'll notice I'm doubling the pieces of cake. I actually end up with 8 times 2. This actually flips over and I multiply. My amount doubles when I cut things into fractions. Or like if I were to say, I'm going to cut your body into thirds, well, I'll see 3 pieces. It triples the amount that I see. So we multiply by the reciprocal. Mult by reciprocal. And that'll hold no matter how ugly the fractions get later in this chapter. If it's division, you are going to multiply by the reciprocal. So I'm going to only do one of these because it shouldn't be necessary for me to do any more. So, oops, don't want that. I want to be multiplying. So here is my division problem. What I do is I keep the first one intact, then I multiply by the flip. Now I'm at a multiplication problem where I can cancel anything top to bottom. Are there any 2's living on the bottom? No, siree. Is there anything in 18 that's living on the bottom? Yes, over here. I can take a 3 out of both of these. Now I multiply straight across. 2 times 6 is 12, and 1 times 5 is 5. So we're done. So what you grab right now is the white worksheet that says fraction review. So you come and show me your notes and grab the white worksheet that says fraction review on the top. I don't think it has a number on the top. It just says fraction review. All right, have a good one.